Testing 1, 2, 3. Not been strict. Are we live? Man, this thing sometimes works and sometimes doesn't. It looks like we might actually be live already. So, hello to everyone who's here. Is it live? I have no idea. Everything's changed how it works here. It is. So you probably all heard the random testing tone as well. Live with sound. Excellent. Wow, what an interesting start. So obviously YouTube have changed how things work again. So just as I was getting used to pressing the live button, making sure we're actually live when I think we're live and not missing it, they've now changed it. So you don't have to press it anymore. Sort of, probably sometimes. Audio is too loud. May I suggest turn your speakers down a bit? I know that's probably a bit of a pain, but my volumes are all the same as they normally are, so I'm not going to change them, I'm afraid. I don't think I'm not. My audio is not clipping or anything, so as far as I can see, we're in pretty decent shape. So, I guess we'd better just get started. So, of course, I have to thank Banggood today for sending this printer across. This is the Ender-3Xs Pro. Yeah, you can probably see the box. It does just say Ender-3 Pro. So this could be a little bit of a strange one. As far as I can tell, this is kind of like a special edition, excuse me, a special edition perhaps just for Banggood, which has some upgraded motherboard and slightly different printed bed surface. Not totally sure. The listing is sort of not very clear. It's like, if you click the link, which is the affiliate link in the description below, but just to read, it says something to the effect of, includes a magnetic, removable, flexible sheet glass. Like, what? It can't be glass and flexible, so I don't know what's in here. It's all a bit of a puzzle. So we'll be doing the same sort of format as we normally do. For those that have not watched before, we'll obviously get the printer out the box, get it all set up and ready to print. In that process, we'll be probably actually taking stuff apart first to have a look at the electronics and stuff inside, see if things are wired sort of sensibly, safely, check out what control boards, stepper drivers, etc. are in there. And then a little bit further down, we'll be actually doing a print, a first print using included profiles, if there are some. If not, we'll be using my Ender-3 profiles from days past. Hi Rashmir, James. Don't all Ender-3s come with 32-bit boards now? Sort of, maybe, potentially, sort of. It's not totally clear. So, I know Creality said that that was going to be a thing. I'm not sure of the exact source of that information, but I had heard the same. However, I'd also heard, I think Chuck Hellerbuck had an Ender-3 after that announcement, and obviously his was not 32-bit. So it may be there's a massive stock and they're trying to clear them. Maybe this is one of the older ones. Maybe they've done an upgrade. It seems very unlikely that they're gonna actually take an Ender-3s that are already built apart and put different boards in. So, well, let's just get into it and see what we've got. Same old packaging that we can come to expect. The old non-recyclable, in most areas, but quite good for packaging sort of foam. In the top, we got some, let's switch over to the old top-down view while we do this. Hopefully some introduction manual. There doesn't look like any SD card or things like that, so this could be interesting. So we've got Ender-3 Pro 3D printer, instructions for assembly. We'll have those up on screen so you don't have to find those yourself. Those will be available, yes, as I said, on the screen when we get to that. After sales service card with a number and a QR code, probably for the Facebook group or something, and some more stuff. Well, it's immediately obvious we've got a flexible sheet, which I believe is not glass. So that's a thing. It also doesn't really seem to fit the bed. It's kind of a bit big. Anyway, let's get into actually getting the stuff out of the box first. We've got a screen here that looks like a very standard looking screen. Doesn't look like anything particularly fancy. Same Ender-3 screen I would expect to see. Not quite sure the best way to get this out. I should really know how to get an Ender-3 out of the box by now. This is like the fourth one or something. 3, 1, 2, third one? I have no idea. So we've got a coloured ribbon cable, which is a little bit different to what I've seen before. And the hot end is all attached, so that's going to come out. Oh, is it? Is it? Maybe not. Yep, I think it is. It's sort of all twisted in. Okay, that's just going down there at the moment. We'll get to that in a second. We got the end of the X with the extruder attached to it. We've got the power supply, which should be a Meanwell power supply. Has it got any Meanwell branding on it? No. Maybe we'll take that apart to see if there is more branding on the inside, but I'd be surprised if Meanwell sell power supplies without any branding on. That would be a bit of a shocker, wouldn't it? So that's the first layer of packaging. In the bottom we've got sorts of screws, fixings and that sort of thing. We've got some Allen key stuff in there as well. Some sample PLA, the X end idler, end stop, that sort of thing. Power cable, again for Europe. I always get the Europe ones because they seem to be, they can ship a Europe one to me quicker than they can ship a UK one to me for some reason. Spatula, filament holder. This looks all very standard Ender-3. Some, they're the uprights. Oh, a UK power cable as well, and the Z stepper motor. We'll just double check to make sure there's nothing else in here. Nope, that's everything. So that can disappear now. Yep, that really flew a bit further than expected. Okay. So there's no glass. So the fact that they list glass on the packaging is maybe what we would say is mildly misleading. Sorry, not on the packaging, on the website. To quote the link, I suppose it says printing, so I'll read the full title, is Creality 3T customized version Ender-3Xs Pro 3D printer, 220 by 220 by 250 printing size with magnetic removable sticker / glass plate platform. So what is it, just random? / version 1.15 super silent mainboard. So in my mind it should have the magnetic removable sticker and the glass plate platform and the super silent mainboard. There's no glass. So if you're expecting to get glass when you buy one of these, well, don't expect to get glass when you buy one of these. Is basically the gist of it. What used to be a slightly fake XT60 connector seems to be now a much better one. That looks like a proper job now. It's actually labelled properly. It looks way better made. So that should solve any of those bed heating. Well, it wasn't so much a bed heating, it was the connector heating up because the contact was poor. We've got one cable, a nice ribbon cable coming out of there. I think before we get onto assembly, let's check out this control board because, yeah, I'm not certain we're going to be getting the 32-bit or particularly silent board that we may be expecting. I need some way to unscrew this. Every time I build an Ender-3, I forget how many parts it's in. Quite a few, it turns out. Shouldn't be a surprise, but it always is. I've lost chat. It's disappeared. Oh, there we go. Is it a pre-release? No, this is not a pre-release model. It's up for sale. It's a specific customized version. I don't know what sort of state the customized version is in. For a start, it said glass plate, and there isn't one, so that's not a thing. Let's flip this up on its side and see if we can get. Oh, it's always those little screws. That's just gone. It's gone. I'll never see that again. No, I found it. Right. I might actually. Should we keep with this view? This will do for now, I think. So let's have a look what we've got inside. So, okay, so the listing said what? Version 1.1.5 super silent mainboard. I'm looking in here and this says version 4.2.2, so it couldn't be further from what it says on the listing. It's not a glass board and it's a different mainboard, but apart from that, it does at least look like an Ender-3. So this is an ARM chip, so it is a 32-bit control board. Unfortunately, they've like thermal adhesived some heat sinks onto the stepper drivers directly. So while we do have a 32-bit board, we're not totally sure what the stepper drivers are. That is kind of unfortunate. I guess I can understand why they do it. It stops heat sinks falling off. So we're going to be powering it on. Well, we're going to be printing with it anyway, so it's not like a big detour, but it just means we won't be able to see exactly what they've got going straight away. The rest of the wiring is fairly typical for Creality. There's like hot glue holding a lot of the connectors in place to make sure they don't come out during shipping, which might sound daft, but can happen. Some shipping forces can be quite extreme. Other than that, well, I've not had any heating or issues like that with my Ender-3s, so looks fairly reasonable from my point of view. What I am hoping is that they've not used the weird voltage step down thing that we did with the CR6 SE, converting the 24 volts to 12 for the stepper motors. Why would you do that? So, because that was what was causing their heating and burn up problem, I believe. So hopefully they've not done that in this case. Right. It'd be nice. I wish I had the like a zoom lens on this top camera so you could see it even better. But hopefully that gives you a little bit of an idea of what it looks like inside. So that's that one out the way. Let's get this back in here. I've forgotten which screws go where, but we'll work it out as we go. Come on. This is the problem with these round ends. They don't hold the screw very tightly. I don't know if I want to dissolve the glue because I've got nothing to bond them on properly at the moment. I think we'll just have to, I mean, the easy thing is just to boot it up, and we can tell by what it sounds like whether they've achieved this silence that they were after. Right, I'm going to take this print surface off for now. It's just going to go up there, just so I don't touch it too much while we're doing assembly. Don't want to get loads of grease on it. It will ruin it before it gets started. So that's a good tip maybe for anyone that's looking to build one. There can be a lot of grease around. Oh, where's the... Oh, it's in here. There we go. Yeah, they always put a lot of grease on these lead screws. And the one place... Oh my goodness. Yeah, grease. Grease, grease, grease. Let's just put that back in there for now. Excuse me. So let's switch over to some instructions and we'll start some of the assembly. So this is a guide that I've just downloaded straight off the Creality website. It doesn't seem to be particularly recent, but I'm sure it'll be sufficient for what we're doing. By and large, it is going to be, well, it's going to be exactly the same as a standard Ender-3 assembly for the physical parts, so not too much to worry about. It's kind of a tried and tested assembly method, I suppose, now. Well, it's not necessarily the easiest assembly. It is actually quite a good amount. Like if you look at something like a Prusa kit, like the Prusa Mark III kit, that's quite an extreme amount of assembly, you know, from like literally nothing. A lot of other printers, 3D printers from China, typically have a little bit less assembly than this, so they'll have like just the 4 bolts that go up through the base. And that can be a disappointingly small amount of assembly if you like to have a little bit of assembly. Whereas this has kind of a good middle ground. Like there's obviously a large part that is pre-assembled, but still a decent bit to do yourself to feel like you've achieved something in the assembly process. So this is all looking standard geometry. There's no like extended height or anything. Looks like physically it's going to match an Ender-3 Pro. I should mention, did I already? Banggood sent me this printer, so there's a link in the description to a Banggood purchase link. What? My English is obviously terrible today. There's a link in the description to purchase it from Banggood. There we go. That's what I was after. Not done a live stream in a while. But clearly a little bit out of practice. So scooching down. Screen information, loading filament. Why are we starting with... Oh, is this not an assembly manual? This is not an assembly manual. Oh man, I really should have... Ah, yes, okay. I thought that was an assembly manual, and it isn't. So we don't have an assembly manual, I'm afraid. It looks like the only one that is included is this. There's no like link or anything to There's a QR. I don't know if I have a QR scanner on my phone at the moment. It's probably just going to be a Facebook group. Yeah, that's not going to be super useful. It's kind of a link to a link to a link with a tracer and a tracker and everything. So that's just a bit of a pain. So sorry about just going to be following the physical instructions today, because that's just the way the cookie crumbles. Let's get some of this stuff out. Actually, I don't think we need those things yet. We need more of this thing. TMC 5160. Where did you find that information? That seems surprising. Because 5160s are quite expensive, I believe. So we've got all the little bags of screws here. They're all labelled, so you've got M4 by 16, M5 by 25, you've got 2020 covers, M5 by 45. So nice that they label them. If you're not familiar with screw sizes and lengths, then you can just go by what's written on the bag. So step 5 is M5 by 45, so we find M5 by 45. So a good amount of grease on the screws. It's not necessarily nice that there's grease on the screws, but it is kind of essential. Some of the ones that don't have that on end up turning up and they're all brown, covered in rust. So while it's not necessarily nice to get it on your hands during assembly, it does help in that shipping process and keeping stuff in a decent condition by the time it gets to your particular country of interest. Ooh. So starting with some Z-axis bolts straight up through the base. Which is this going to be? I think this size. Oh man. .427 uses 2225 drivers and the 422 uses 2208s. Version difference is the drivers have different pinouts. I would expect them to be 2208s, or the ones that are very similar, like a cheaper version. I think that's the 2225. They have the general features that most people are looking for without being too expensive or having features that people aren't necessarily asking for. So they kind of meet all the bare minimum requirements, if you like. And then we want the other one too. Probably making this look a little bit more awkward than it needs to be. But that's because I'm obviously trying to do it on camera, so not necessarily getting the optimal angles for assembly. Or for cameras, apparently, because I forgot to rotate the camera. Let's put this up here. I'm sure the Allen keys that are all included, there is a whole set. I'm sure there's ones of suitable size, but I just prefer to use my own tools. But obviously, if you don't, you can use the ones that are provided. The board was, I believe, the 422. We've got the hot end just kind of dangling around over here. So there we go, that's your two Z uprights in place. Yeah, apologies for Streamlabs bot being a little bit aggressive. Apologies, yes, it can be a bit much. But I'd rather have that than people being able to spam. So now we apparently just go straight towards the front for the display. So display fitting is really, really simple. Just 2 screws. And I believe these are M5 by 8. Didn't see those. M4 by 20. M4 by 18. M5 nuts. Ah, I just acupunctured my finger. This is the big downside of acupuncture needles in bags with lots of other things. I have a few of these already, so to save myself from poking myself again, that's going to disappear. Ow. Alright. So it's actually the power supply as well in this step, so a couple of things to do. First we'll get the screen on, the M5 by 8 screws. I'm not sure why these are silver when everything else is black. Doesn't really matter, but seems like it would have been wise to make them match everything else. It's probably 2 for something else. Glad you took 3D printing instead of archery. You're smart. There's a bit of a difference in size between a flipping arrow and an acupuncture needle. Thanks. Yeah. Direct input voltage. So if you are in, it's USA, isn't it, that has 110 volts, or any other country that uses 110 volts mains, you do need to flick this red switch in the side from 230 to 110. But for Europe and UK that use 230 volts, I believe it's all of Europe, right? Oh, well, this has not been assembled properly. Ah, I know what we're going to do. We're going to take it apart. I wouldn't necessarily suggest doing this. Taking apart power supplies can be a little bit of a risky business. But for the purposes of checking what the branding is on the power supply, I'm going to do it quickly now. And it's also not been assembled quite right, and the cables are slightly dodgy length, and they look really jammed in. That does not look particularly great. Let's see. It is a heated bed. It is a heated bed. Your standard Ender-3 heated bed. There we go. It is a mean well. There you go. Just so you don't have to take my word for it. There you go. Meanwhile logo. Is that close enough? Do we need it even closer? Really big. Come on, focus, focus. Yeah, we go. So you've got 350 watt, which is actually quite a bit. I think that might be more than previous versions. But I'm not 100% on that, so don't quote me. Let's get that assembled properly. Yeah. The wiring's not super great here because you've got this thing with connectors all going, you can kind of probably see in there sort of, obviously the connectors from this all going down, and you've got the connectors from the power supply all coming out this direction towards the camera, and they basically all just meet in the middle, and they're all kind of crossed over and all jammed in strange directions. So Well, I'm not necessarily expecting a major problem to be caused by it. Stuff is strained a little bit more than I would, well, yeah, I wouldn't design it this way myself, put it that way. I'd want a little bit more room in there to make sure nothing is strained. It's just got to push a long way on as well. Yep, connectors are right up against it, but at the end of the day, they're not going to be moving very much, if at all. So I'm not massively concerned. It's just not ideal. Blimey, 116 people. For anyone that's new or not watched before, please feel free to subscribe. We do live streams like this, generally on the weekends at Sunday evening, like this one. Doing assembly of printers and first prints and that sort of thing. Of course, don't forget to like the video if you've enjoyed it so far. And of course, share it with people that also might be interested. Yeah, why not? Do that thing. Okay, so now we're taking a look at the power supply. 350 watts, mean well, 24 volts. Good, 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 good. This goes this way round. We're going to be putting that on there like so. But we need some screws to do that. For that, M4 by 20mm screw. Again, nicely labelled bag to know what we need. Huh? So this should go through here. This should go on here, and this can go on here. Here, here, and here. This is actually really strange. The concurrent viewers is just going like this the whole way through so far. It's like people have joined and just nobody's left. I'm sure people have left, but the number of viewers is just steadily increasing, which is quite nice to see, especially as I haven't done a stream for a couple of weeks. So we got the power supply on now. That's looking pretty good. It is a little bit close to the bed. I would imagine this upright is not quite straight. They never quite are. It barely clears the bed, like barely. I wonder if we can find a way to try and straighten it up a bit. Yeah, you can. It's quite a way off. It's a long way off. If I press this flat against here, then the gap over here is like 6-7mm. So I do kind of want to sort that. To do that, we're going to turn the printer back over again, loosen these on the bottom. And we're going to find a way to strain it up a bit. It's not going to be particularly easy to do. But I've literally just stuck my finger between the bed and the power supply enclosure to try and make that parallel. Obviously, it's all kind of flexible and that's not perfect, but it's much better than it was, and that's the most important thing. We're not looking for perfection. Well, personally, I'm not. It's not a perfect machine. So trying to achieve perfection on something that is imperfect, I think, would be daft. But we got much better there. It's now almost too much the other way, but you can't win them all. This one's also kind of twisted. This one's going to be a bit more difficult to do now because we've got more stuff. It'd be nice if they had some little jig that was included to help you get these things straight, because, well, I've just said perfection is not important. Still trying to make it square. It'll basically just reduce the wear on the wheels. It should help you with getting square prints and that sort of thing. So a little bit of correction there. We might actually have to do the same thing a little bit further on, maybe towards the end of the print. There might be an easier way to align it later down the line. Right. Next on the assembly, we have the end stop switch. So this is just a small physical micro switch, which has just a little lever on it, placed on a small bracket that slots nicely into the extrusion, and that will set your Z height position. There's a little kind of nubbin that sticks off of this, so you can get it in what in theory is the correct place, but every printer will probably vary potentially quite a bit. So be prepared to move this up and down a little bit if you need to. What you want to end up with when you're doing your leveling is to have the wheels, obviously primary objective is to make the nozzle the same distance from the bed all over. That's assuming your bed's flat, but on the assumption that your bed's flat, making it the same place, the same position, same distance rather, from the nozzle all the way over. But in the same time as doing that, you do have this kind of overall height that you will be able to set, and that's what you can do with this. So if you're leveling your printer and you get to the point where all the bed leveling knobs are really, really loose, but your bed is level, I would personally try and tighten them up a bit and move the whole lot down by moving this down a little bit. Because when these are quite loose, they have a tendency to wiggle looser, whereas if they're kind of at least medium tightness, maybe halfway-ish, then that will provide enough friction force, it'll provide enough friction between the two surfaces that they won't wiggle loose. And the wiggling loose would obviously mean you have to keep re-leveling, which can be frustrating, or a bit of a pain, or at least a barrier to getting printing. So that's just a quick tip, if you like. So placing this on, we've got two T-slot nuts. It holds into the extrusion like so. And then we've got this little thing down here. So we place that there in the corner. Bob's your mother's brother. T-slot nuts will probably force it into position a little bit. Try and keep it as vertical as you can. I feel like this has become an assembly guide. When did I wasn't planning to do particularly an assembly guide, but here you go. This is now an assembly guide for the Ender-3. Apologies for the slightly exuberant bot. I know, that was just symbols. Yeah, guys. Try not to get over the top on the symbol. Why is there random? Oh, it's part of the packaging. It's a big old silicon sock over the hot end. Kind of nice. Not necessarily ideal, but it looks pretty good if nothing else. So we've got the tops on, screen, power supply with a switch. We've got the end stop switch for setting the Z height. We've made sure, obviously when you do these, making sure those T-slot nuts rotate into position to grip onto the extrusion. Now we're turning the printer all the way around to do the, oopsie daisy. Make sure that doesn't happen. Because this is all attached, you've got this thing wobbling around the whole time. Try not to let it drop on the floor when you're building your printer. It is fairly robust, it shouldn't do any massive damage, but obviously try to avoid it. So stepper motor here. This is a coupler, so it basically converts this smaller 5mm shaft, which you get on these NEMA 17 motors, into an 8mm hole, and I sort of collet, in order to insert the lead screw, which is this screw-like device, which converts your rotational motion into the vertical linear motion. And if we find the right screw, fourth time lucky, and we can tighten it into here. I've kind of lost track of chat a bit, so I don't know what you're all talking about. Personally, I'm not a fan of glass beds at all, regardless of how flat they are, because when stuff sticks just a little bit too well, glass bed go bye-bye. Flexibles, if you can't afford a quality flexible bed, these ones that are kind of very well, a bit more cost effective, not quite as good, but still better than glass, I would say, although obviously not as flat. Be interesting to see if they fix this issue. They didn't on the second Ender-3 that I had. Typically this lead screw is offset a little bit from the position on the nut, so I end up quite often putting a 1mm thick washer, I think that's like an M8 or M10 washer, in the gap between the two. Of course you could 3D print a spacer as well if you like, because if they're not aligned, again it's just a little bit more force, bending the lead screw, extra force is unnecessary on the stepper motor, making it wear out quicker, replacements, damage, jamming, and all this sorts of stuff we don't want. This or a Prusa Mini? Depends what you want to do, my friend. If you just want to print PLA for like aesthetic objects and maybe some practical stuff around the house, but nothing too engineering much, then Ender-3 is a great low-cost option. You have to be a little bit more wary of the fire safety stuff, but Ender-3 is a better low-cost option. If you want to push the boundaries a little bit more, but you're not printing this size volume, then from my experiences, Prusa Mini is fantastic for things like PTG, and you can also print the Prusa PC blend, you can print ASA. So the Prusa Mini just gets you that little bit more high temperature stuff, a lot of ease of use, a lot of support as well. So while I can't give you a definitely get this one, those are maybe some of the things you would maybe want to consider. So I have a quick question for everyone that's currently watching, if you please. Given that the number of viewers is increased over time, I'm interested to know where you all found the stream. Because I would have thought if it was live on the YouTube page, we would have had lots of people at the start and it's kind of steady. But it seems like more and more people are just gradually, randomly finding it. So did you find it on YouTube? Has somebody shared it somewhere, or what? Obviously, don't have to answer if you don't want to, if you're busy and just kind of listening. But it'd be really useful for me to know kind of where people are coming from and how they're accessing the stream. Step 5. So now we need to kind of start on the assembly of this whole X carriage that holds this bit and this bit over here to do the whole kind of hot end movement and motion of the uppy downy and the lefty righty. So to do that, we need this extrusion piece, notification, recommended, YouTube recommended the stream. Thanks, Tyler. Don't make me responsible for you, you not doing work. Subscriber, notification. I guess YouTube just gets a little bit slow with notification maybe. Or I guess people are busy as well, so you don't necessarily see it immediately. Of course, thank you everyone for being here. I do appreciate it. It's nice to catch up on all sorts of things. And it means I can sort of talk to myself without being a mad person because everyone's listening. This bit is always a weird kind of thing to orientate. There's a lot of kind of stuff going on. There's two motors. Like, if you're not necessarily used to looking at 3D printers, it can be really confusing. So let me just go over kind of quickly what we're really looking at here. So obviously the two main bits here are these stepper motors. So the silver black silver here and the silver black silver here. These are two big heavy stepper motors. This one on the top here, which has the little kind of brass bit on the top and the spring, this is for feeding filament. So this is typically what you'd call your E-axis or extruder. And this is going to push the filament towards the hot end via some other stuff which will fit in a minute. This other motor around the side has a small pulley on it, which has some teeth attached. And that's going to go around the belt and that will drive your X-axis. So this is your X-axis motor and this is your E or extruder axis motor. The other things you've got here are these black wheels made of Delrin or POM or acetal, loads of different names for one material, depending on, of course, who you buy it from. These are obviously what's rolling onto these extrusions. So these are V-slot extrusions with these V-slot style wheels. And the last thing you want to look for is the brass nut up here. And this is the trapezoidal kind of nut. This is what kind of goes onto this lead screw that we just fitted. And that allows for, well, allows the uppy-downy from the rotatey-tatey. So you've got this E-rotatey and this E-goey uppy-downy. So that's how that works. So in terms of orientating this correctly, let's just bring the whole printer around so you can get a kind of good view of where it's going to end up, and that would probably help with how it's going to look and how you can get on with the assembly. So the easiest thing to probably recognize is the fact that there's a QR code on the front, and so obviously branding goes towards the front. I'm going to take this off because I think it looks really nice when it's all kind of uniform black color. Matte black everything and all that. So you've got these V-slot wheels which want to be pointing kind of through the slot like that. Extruder pointing upwards. And then this comes over here, over the top, and will sit on this one like that. If we bring this up here, you can see, so from this position where we have the QR code on the front, extruder on the top, this would sit over here like so. But we're not going to get quite to that yet. We do need to mount the thing to the things first. So first thing you need is the extrusion with all the extra larger holes cut in it. With the extruder in this direction, that in that direction. This goes on the back here, like so. So basically what you're looking to line up, let's bring this back down again. The things you're looking to line up are this cutout here, which has this kind of larger cutout, which you don't have. Okay, they're kind of in pairs on this one. But in this individual one here, this wants to basically line to here. So you've got this face of the extrusion lining up to this face with this screw. So that goes on there like that. See, from there, like that. Can be a bit difficult to orient that part, so hopefully that helps a little bit. In terms of screws, I've got two M4 by 16s. And those don't go through. YouTube recommended, YouTube subscriber recommended is just now. Following a lot of 3D printing stuff lately. I guess it's an increase of people being at home more. Especially with all these extra lockdowns now happening. Let's not talk about that though. This is 3D printing discussions today. Think happy thoughts. So there you go, there's an extrusion attached. You've got the end stop switch at the front here. and the extruder on the top. Cool, excellent. So with that done, we can move on to step 6, which is basically the other end. So again, you've got this plate with the wheels on it. Obviously, these wheels on this one need to align with these wheels on this one, so we know it's going on kind of this side. And again, this way you've got this larger cutout on the extrusion that's going to go over one of these holes, and in this case, sits on there like so. Come back around the other side, and we put our screws in the back. When you're doing the tightening down here, you do want to try and make sure everything is kind of, I don't know what the correct term is, aligned parallel. So on this one here, on the one that we just finished already, this part of the kind of the bracket behind it has a nice flat top, so you want to keep that level or parallel, collinear, coplanar with the top of the extrusion. And likewise on this bracket, you've got kind of a flat top, and you want to keep that aligned flat to the top of the thing. That will just make sure the assembly goes nice and smoothly once we get it onto the printer. I like to get these kind of tight-ish so they don't move. Check that everything's flush how I want it to be, and then tighten them down. These screws, as they're quite small, you don't need to apply huge amounts of force to tighten them. To the point where they're kind of tight-ish is probably quite enough for small screws, especially as we're screwing into aluminium here, which is a soft material. So if you go too much, you will just rip the threads straight out of the aluminium, and then you won't be able to screw into it, which would be a bit of a bother. I subscribed but didn't hit the notification bell, so when I was browsing for something to watch, I saw you were live, assembling an Ender-3. Cool! Yeah, so it seems like people just come across it as YouTube recommends it a bit more. It's nice to have YouTube recommending stuff for me for once. A lot of the time they just tend to not bother, it seems. What does the 3XS stand for? I wish I knew. I reckon it stands for extra stuff, but there isn't really much extra stuff. The listing kind of says it has a glass build plate, and it doesn't. It just has the standard one which you get with the Ender-3 Pro, so that's just normal. But you do get the extra stuff control board, which is the 4.2.2, which is a silent 32-bit board. Silent, it's not actually like no noise, it's just much quieter than your standard 8-bit and A4988 kind of setup. A 32-bit control board is something that I would typically recommend for an Ender-3 upgrade. It's a really useful thing, mainly for the noise, but also for the speed of using the interface. It just makes it a bit quicker and easier to use. So nice that you can get one with a decent board included. Oh yeah, we still got the instructions on screen. Yeah, they're there. So once we've got this whole carriage looking like this, we need to get this on. So this is your hot end. This is the bit that gets hot in order for the plastic to squeeze out of. Let's just give you a quick overview of what we're looking at. So we've got more of these black wheels, which you should be familiar with from the previous assembly. Of course, they're going to be sliding along this rail. Around the front, we've got two fans. You've got a fan behind this kind of metal cage, and that's going to be your hot end cooling fan. So the hot end is the red bit in the back. We'll look at that in a second. And that's basically cooling a heatsink to make sure keeps the cold end cool while the hot end can stay hot, kind of wrapped in this silicone sock. On the side, you have your part cooling fan. So there's no shroud or cover on this one. This blows air, well, sort of out this duct, but it's not necessarily very well positioned. And that's designed or intended, the intention is it cools the part. So when you're printing with PLA, you want to get quite a lot of cooling to make sure it solidifies nicely. Whereas with other materials, maybe like ABS or ASA, you want to tend to reduce the part cooling fan in order to reduce the amount of cooling on the part, because otherwise it can warp too much. Right at the bottom, you can see the black silicone sock and the brass nozzle. under the silicone sock, I'm probably going to regret taking that off. I'll never get it back on again. You can see the heat block, and on this side, how much closer can I get this? Everything starts to get a little bit small in here. So here, yeah, on this side here, just there, you can see where the heater is going into the heat block, and just next to it is a thermistor behind a small screw. Why they're still using that screw type, which is from like 10 years ago, I've no idea, but there you go, that's what they have. From the top, you can see the red heatsink, which is again kind of the cold end side of the what you would call hot end assembly. And then you've got this white tube coming out the top, which is a PTFE tube, which is a low friction tube, and that's where the filament goes through. And then of course you've got this wire assembly, which is all your power and thermistor wires and stuff like that. So now, let's see if we can get this back on. What's the chances? Oh, quite easy actually. That was a pleasant surprise. Cool. So we now need to slide this onto here. This is going to go onto here like so, I believe. Oh, has this decided? Really? Really? Yes, really. So for anyone that's following along, don't do what I did. You apparently need to, despite these items both being in the same step, you need to put the hot end on first and then this end plate. So that's kind of frustrating. I could have sworn I didn't have to do that before, but apparently this time we do. So let's just remove these two screws quickly. And then with the extruder facing upwards, this comes onto the end like so. And this should roll smoothly along here. Now we can go back to the plate, which we've just removed, and reattach it. Of course. Streamlabs bot's having a bit of a kind of band fest today, isn't it? The spot is overzealous. Yeah. I did actually look between, well, a couple of weeks ago now, after one of the streams where it was particularly active, and it's really not very simple to tune. I don't have the time to tune it, so we just have to be a little bit careful, I'm afraid. So now we've got all this together. Obviously this can now do the movie thing, but we've got no belts. We've got no way to kind of contact this and make anything actually happen. So what we need to do next is add the idler. The idler, we call it an idler because it's not powered by a motor. It just kind of is idle. It kind of passively responds to motion rather than triggering it. And this is going to sit opposite to the end which the motor is on. So we've got the motor this end, so the idler goes on the opposite end. And that will allow the belt to have a full circuit and therefore go all the way around and control some of the motion. Now, I'm not going to do this too tight yet because we've got to get the belt in there as well. We're going to use this small bracket at the end to try and help us tension the belt. So once we get there, we'll do that. So this is a generic 2GT belt. So it has a 2mm belt pitch, which means from one tooth to the next is 2mm. And it's got these brass ferrules on the end, which are not going to fit under the wheels. Are you kidding me? It looks like they've increased the size of the ferrules. No, It's just not quite clamped in quite the same way as they used to. Maybe they used to fit under the wheels, and oh no, that one fits. Okay, looks like we're going that way then. So this is where I'm just basically pushing the belt along the path which it will end up taking. So it goes over the end there, back around the bottom, all the way back, under. Not having much luck with going past these wheels. There we go. There we go. Wheel comes all the way up the back here. No, what am I doing? It doesn't go past the bottom one. Sorry. I'm trying to do it from memory and failing. You don't go under the bottom wheel. And what you have is in the bottom these two slots. Maybe not super difficult to see in the light. There you go. So you've got a slot here and a slot here, and these brass ferrules, they just kind of act as stoppers. So you slide the belt in, and the brass ferrule just stops it coming out again. And that's all you need. It only holds it in one direction, but the belt will only ever pull in one direction anyway, so that is considered adequate. The other end of the belt, we're just going to poke through the motor hole, make sure it's not twisted in any strange way, bring it back out, and obviously making sure to wrap it around that tooth pulley, all the way out again to the same place, slide it in, and there we go. So now we've got both tucked in nicely, and that looks about okay. So obviously tension now is important to get. I mean, some say it's important to get very right, and it is kind of important to get the amount of stretch right. Obviously if you overstretch it, then you get parts a little bit bigger than you want. If you understretch it, it can A, sort of fail, and B, if you under tighten it, it can fail because the belt can jump off the teeth, or you just end up printing parts that are a little bit smaller than you expected. Stream frozen? You sure it wasn't me? Just pause for a second. So just by pushing, obviously these were loose here, so we keep them loose and that allows us to move it. Try and keep it straight, keep the belt path aligned, and then with a bit of force applying outwards, hopefully you can sort of see, we can you do sometimes have to take 2 attempts. Sometimes when you tighten a T-slot nut, which is obviously the nut on the back of this screw, it can not quite rotate into place, in which case it feels like it's tight because you can't tighten the screw, but it's not clamping. So if you just kind of spin it loose a bit, that'll push it kind of back out, and then spin it tight, and that should pull it round into position. With the ones on the end, like here, you can kind of see, but the ones in the middle can be a bit more difficult to know if you've got it right. By doing the hidden one first, it just means that you can feel whether it's tightening or not. So, not super tight belt tension, also not super loose. You've got some nice smooth motion. I've seen people use magnets to put them in the clamped position and slide into place. Yeah, I don't think you really need to do that at all. you just kind of loosen them and tighten them again. As long as you loosen them back enough, then tighten them, they'll just move into place. Right, next instruction. So we've got step 8 done, that's the belt assembly. If we move on to 9. So for 9 is just basically assemble this onto this. So we're going to start by making sure we're lining it up correctly. So we've got the logo here, this whole face moving forwards, and the nozzle pointing down towards the bed or the ground, work surface, whatever you want to use as a reference. Obviously we've got a big gap here with wheels, and we've got another big gap here with wheels, and these are just going to slide over the extrusion, and you want to line up this T-slot nut with the big greasy lead screw which we added earlier, and hopefully it'll go on without a hitch. As always, the lead screw doesn't quite line up. It has to be bent into place, which is really not very good, but there you go, that's the way it is. Judged by the amount of force that I need to get this on, it might be a little bit tight. If you can't get yours on, firstly just be really sure that the alignment is correct. Obviously you're going to be applying force to the lead screw, so make sure you turn that in order to get it to move down. Then make sure that your brackets are aligned with the extrusions correctly so they're nice and flat. And then if all of that is not quite right, you can loosen the nuts on the back. So you should have... So this is different to what we've already worked with. These come kind of ideally pre-positioned for the factory. But in the case that yours don't, there's like a small flat spanner in here. I believe it's this one. So the larger end, behind this wheel here and this wheel here, there's an eccentric nut, which is, it looks kind of like a bigger version of the nylock nut at the back, but it's right next to the plate. And it means when you turn that, it will move the position of that Delrin wheel just a little bit, kind of, well, in a circle, excuse me. It will move that by moving it out a little bit. It'll just give you a little bit more wiggle room. And then if you need to tighten it up again after it's on, you can do that. The wheels shouldn't be really, really tight. You should be able to get a nice smooth motion. Unfortunately, because you do the lead screw first, it can be a little bit difficult to tell, but I think mine's just about okay. It's a little bit on the tight side. Yeah, it is really on the tight side. So give this a bit of adjustment. That's really quite... What can also be useful to do is to just loosen these screws at the back. Retighten them. Just to match the spacing of the frame. There we go. By the way, don't forget to like the stream if you're enjoying it. Don't forget to subscribe to see more stuff like this in the future. We don't really have any adverts or sponsors. Thank you to Banggood, of course, for sending the printer to me for the purposes of doing this video. For my sanity, as well as for yours. So, I don't know if it says to do this right now. What it does say to do, I've got grease on my hands and I've touched my face, so I've got grease all over myself. When moving the whole carriage up and down, I use the coupler that I pointed out earlier, which is not covered in grease, so reduces the amount of grease that you might have on your hands. We're going to loosen the nuts around the lead screw and retighten them into a position where there's less strain. Unfortunately, it doesn't move very far at all, but hopefully that'll do. I don't think it will. I think it's still going to be a lot of gap. Yeah, I would still recommend doing the same fix that I mentioned earlier. I can visibly see the lead screw is further from this extrusion at the top than it is at the bottom. So I think it's normally out by about 1mm. So a small 1mm spacer, that could be like a nice introduction to a little kind of CAD project. Just a square plate with a couple of holes in it. You can hold it behind the stepper motor as you mount it in. That'll give you a nice little offset, straighten out that lead screw nicely. So that's step number 9. Moving on to step number 10. We've got this last part to place on the top. And for this we want M5 by 25. As always, they're giving you more screws than you actually need. So 4 screws in the top. Oh, that's just totally missed the hole. To be honest, you probably want to keep these screws loose. These ones at the back that I re-tightened, probably best to keep them loose until after you've done this, because this top piece can really change the dimensional size that you've got here. Can pull it in depending on what the hole spacing in this piece is. So keep them loose and then get this tightened in. And then after that, tighten everything else back up again. I don't think that really adds much. We've got the whole widescreen shot already. That's why we have so many camera angles, so I can't forget to have one to change it. And try not to be too overzealous with the tightening of the screws. Tightening into aluminium, so it can be quite soft. So with this level, tighten those screws back into there until firm. Nice. So next up, we've got some small plastic parts to put in the ends. These just cover these sharp corners. I do recommend using them, even though they don't look like they add much. When you scrape your hand on the edge, you'll be happy it was plastic and not metal. So that's that in there. Step 11 is the spool holder. So you should have some M5 slot nuts. I believe they're M5. Yes, and 2 M5 by 8s. These are the 2 that we didn't use earlier. Very easily push those 2 into there. 2 slot nuts onto here. So that's just like that. Please focus, please focus. No, hopefully you can sort of see what that's going to be anyway. Then we can put the spool holder bracket on. They've changed this from being a whole threaded part, which I guess is kind of nice. I think they generally tell you to put it on the other way around to what I do. Yeah, they tell you to put it on, so let me just show you. They tell you to put it on this way, but when you put it on this way round, this part of the angled bracket takes up a part of this width, and so some spools just hang slightly off the edge. But if you turn this round, then you get the flat face up against here, which means you get the full width of the spool holder to be able to mount a spool. It's totally confused why they still tell you to do it the other way in the instructions, because I've found no downside to doing this. And this is what I do on all my other printers. So that just mounts on the top, like this. I tend to mount it as far over as possible, and sometimes if I'm doing a fair number of smaller prints, I might even, that's two slap nuts not working properly. Sometimes I mount it on the side, because if this is only moving between like here and here, then I can have it off the side and it gets a slightly better, cleaner filament path. But generally, doesn't matter too much on these new ones because they have the brass entrance. So the extruder doesn't wear away like it used to. That spool holder fix. Now we've got a whole load of things to plug in. Let's get rid of a lot of this plastic and stuff that's sitting on the desk. Side cutters. Got some zip ties here, not sure we're going to need them. Little spatula. Generally, with a flexible bed, you're not going to need a spatula of any kind, because everything just tends to peel off nicely. So, if we start, it's just really close up in my face. Okay, that's weird. So if we look down here, so this is the end stop we mounted quite a lot earlier, and this should plug into, I can't see where it is. It goes up to the base, the bottom I should say. That goes right in there. So that's the signal to the control board. If we turn around the back, we'll find quite a lot more to do. So starting at the top, we need to attach this small brass fitting with the coupling kind of plasticky thing at the end into the end of the extruder, and hopefully one of these spanners that's included will fit that. It does. So we can get that again, try not to overdo the tightness, and put that PTFE tube in there, pull it out slightly, pull the plastic part out, push the PTFE tube in, and then put a small clip, the boo clips that are included, and that stops any back and forwards motion. And then we're kind of done with this little bag of stuff too. You can kind of fit the cable into here, but I tend to find it comes out, so that's how you would do it, but not 100% important. Moving down towards the base. First off, we have the Z motor, which is this short cable that looks like it will never reach anything, but if you get it in the right direction, this just pokes out here to this motor on the side, just in here. You got the big red and black cable, keep that below everything else. That can go literally right down the bottom. Make sure that there's no cables that can get in the way of its motion. Right down the bottom, there we go. And this power supply cable can plug straight into that. So this is your big yellow connectors. They're going to deliver power to the rest of the board. Nice and stiff, but they do slide together and then they stay together, so that's pretty good. Next up, we've got this very long cable that sticks off the back, quite a few connectors off of it. They are labelled, so you've got one that says E, one that says X, and one that says X. So 2 X's and 1 E. So you've got up here, so 2 4-pin connectors and 1 3-pin connector with 2 wires in it. So the 2 4-pin ones, well, there's 6 pins actually, but with 4 wires. These are your E and the X, so these are going to be for the motors. So remember, as I pointed out earlier, this one at the top is E and this one down here is X. So we can stick that in the side there. That's for E, and then this one in here for X. Now they don't really have any specific cable management method for this, which is sort of unfortunate, but we do have some zip ties, so we can zip it to this other cable here, which will help a little bit. This smaller cable, the 2-pin, well 3-pin with 2 wires, slots right into the end here. So probably quite difficult to see on camera, it's quite dark in there, but there is a little connector that goes to the back of the end stop. So again, that connector just reaches round into there, bring the cable back around the side where the others are. Add a couple of these zip ties onto here. Yeah, the cameras are all on autofocus, so apologies if they do take a little while to focus in. I just can't be spending half the live stream focusing cameras. I'd never get anything done. I'll cut these off. That just gives us a bit more control over the position of those cables. So there we go, that's all wired up now. The last thing to do is the ribbon cable. So this one in particular is a rainbow coloured one. Sometimes they're grey, sometimes they're rainbow coloured. Which one does it want us to plug into? XP3. So if you look to the bottom of the screen, which might be quite difficult now that the printer's assembled, but if you look to the bottom of the screen, there are 3 black plugs at the top next to each other on the back of the display. You can see that they're labelled underneath in white text as EXP1, EXP2 and EXP3. So you want to plug this one into EXP3, just like so. There is like a notch on it. It is keyed, so it will only go in one way round. So don't force it. It will go in as long as you get it the right orientation. Now, the management of this cable is not necessarily ideal. If you want to, you could probably put a zip tie around the extrusions to that, just to make sure that it doesn't kind of get caught under anything that you don't want to get caught on. For example, the moving bed. Getting stuff, oh, that's a bit longer. Okay, never mind. Right. Focus, you. For now, we don't know exactly what the steppers are, but we're, based on a little bit of research that some of the other viewers have done, it looks like they're 2208s or 2225s, which are a variant of 2208s, I believe. So they are silent, and it is a 32-bit control board. Has an ARM processor, as opposed to the classic Atmega 2560 or 1268 or whatever the other versions are. Yes, 32-bit control board. So 11 was spool holder. Step 12 is the E motor, X motor, power, Z motor, screen, PTFE tube, X end stop, and Z end stop. So that is it for all the instructions. So if you're now confused as to what to do, you probably wouldn't be the only one. So now your printer is, in theory, kind of ready-ish to use. Apart from it isn't. But it is ready to turn on, so that's the next thing we're going to get on with. It's a bit of a shame they don't give you any more instructions past that. I imagine quite a few Ender-3 users are going to be first-time users. So let me walk you through now how that kind of process would work. Just clearing up the desk so we can all see what the hell is going on. I will actually use, do I want rubbish? I don't want to use rubbish filament. Let's use some blue. Blue. Blue just because it's kind of easy to see on camera, hopefully. It's not very much, but hopefully that's going to be enough. So, power plug, where's that? Down here. Yes, hopefully there's not noisy fans. That was my massive problem with the Ender-3 V2. I couldn't bear to use it. It was so loud. It was like otherworldly loud. We're going to switch. It's never really easy to see what's going to be useful. Maybe we'll do this, something like this. Maybe get rid of this one for now. Right, so power cable. Hopefully you know how to use one of these. Plug it in, turn it on. So this is the point where we hope that we don't get magic smoke. We want to keep the magic blue smoke in the machine and not extract it at any point. So we'll just turn it on and hope for the best. This looks like a reasonably good start. So if you fall into the category of most people, the first thing you would probably want to do is print, but that's probably going to cause some problems if you just immediately try and print. The reason being, the printer doesn't really know at the moment the distance between the nozzle and the bed. So what we're going to do first is level the bed. To do that, we need our bed surface. Actually, I'm not going to put it on just yet, but we are going to preheat. So you can use the controller. Don't think there's anything particularly special. What is nice about this 32-bit control board is you can see the menu moves quite quickly, kind of responds immediately to your inputs, whereas the 8-bit one can sometimes be a little bit slow, especially when it comes to reading their like SD card files and all that kind of stuff. So if we go to, so from the main menu, just press it once, down to prepare, and then preheat PLA. Preheat PLA. We're going to do both, so we can just go for this one at the top. So that's going to do a preheat. So it's going to heat up the nozzle / hot end, this part up here. You should have this fan spinning at the front. If you don't, then you need to really check your wiring. I mean, hopefully it should be because it's been pre-wired. But if that's not heating, if that's not spinning, then you're going to have a cooling issue. So make sure you have that. But this one at the side shouldn't be spinning. Why is that spinning? That's the part cooling fan that should not be spinning. Let's just go to control. Sometimes you can enable the part cooling fan in order to increase the cooling rate on the nozzle because it blows very close to it. But we're not trying to cool it down, we're trying to heat it up. So you can see the temperatures on this main menu running. So this is Marlin firmware for those that are not initiated. So you're running target of 200 degrees on the nozzle side and the current is 157. And you can't see a blooming thing. Let's just move that camera so we can see what we're talking about. Apologies for the humming and singing. It just sort of happens. Apologies for standing in front of the camera. I'm just going to try to get just kind of zoom this into this screen so you can see what the screen is displaying when I select things. Unfortunately, it's very, very bright. It was almost better at the darkest setting, wasn't it? Can't see anything else, but you can sort of see the screen. Is that visible or is that too dark? It looks a bit different on the stream to what it does on the camera. Literally right over the top of it now. Damn it. Now it's right in the middle of the other camera view. It's sort of out the way, just about. Everything's now just like this part of the screen. Okay. So, as I was saying, you got nozzle temperature on this side, so now we've reached our target. It's going to probably wave around a little bit between 201 and 199, and we use a PID auto tune to try and fix that. And then on this side we've got the bed now at 60 degrees. So we're going to do a home now, and that will bring the nozzle to, well, bring all the motion components to their end stops. And the reason we've not put the bed on is the nozzle could crash into the bed, and we would rather damage this magnetic surface underneath than the actual print surface on the top. I always forget what these commands are. Auto home. It is reasonably quiet. Got a bit of buzziness, but not too bad. I believe quite often the nozzle does home off the corner of the bed. So generally not too much of a problem there. But it's best not to put the surface on anyway, just in case. Surface you want to protect at all costs, hence why I removed it quite early on. It does have a bit of a hum actually, this. I wonder how they've configured the micro steps and stuff. It might not be set quite right in the firmware. Okie dokie, interesting. So, it looks like the bread springs are fully compressed. So the nozzle is quite away from the bed at the moment, which is sort of good in a way. What I'm going to do now is I'm going to move the bed all the way to the front position. No, wrong setting. Lead axis, Y axis. That should move it all the way to the front. And that will allow us to place the print surface on, and we're also going to get a piece of paper. The paper is going to be used as a gauge, so to help us feel the position of the nozzle. Stick that between the bed surface and the nozzle. Kind of keeps a bit of temperature difference between the two as well. If I just nudge this out. So there we go, that's the screen sorted. So now we can start the leveling process. I don't think there is any assistance in that in these menus. Sometimes you'll have an auto level assist, which will move the nozzle around the bed to help you get to the different places. In this case, we don't have that, so we have to do it manually. And I would recommend doing it manually rather than moving everything by hand and disabling the stepper motors. The reason being, once the stepper motors are engaged, they're holding a specific position, whereas when they're not, any bit of movement can cause them to rotate. So what I'm going to do is try and position the nozzle according to where the screws are underneath. So we want the nozzle directly above the screw position, and then we're just going to undo it because they're at maximum tightness to begin with. In fact, we're probably going to need to undo them all quite a lot because they are a long way from where they should be. Keeping in mind what I said earlier about end stop switch position. Mine's kind of at the minimum at the moment, so hopefully this is good enough. So you want to kind of feel a buzzing, a kind of small scratching. You don't want it jammed under the nozzle. That should be okay. And then we'll go back towards the rear and do the rear one. When you do a large amount of movement like this, it's a good idea to go around more than once, just because the motion that you do on each dial, each knob, each leveling point will undoubtedly affect the others. So by doing it more than once, you kind of overcome some of that issue. Obviously, the larger the effect, the larger the change in distance with your Z-axis by dialing the knobs, the bigger the issue can become. So, and I got a bit over the top with loosening these earlier, so I might have scratched the bed slightly. Oops. But at least there is paper between the two, so it's not too bad. Okay, so I'm going to go back to the first point. So moving X back to about 20-ish. 30, I think, is probably good. Yep. Oh, and we need a little bit more Y. So again, just feeling, just to be careful, and keep moving Y all the way to the back again. It's quite noisy, there's quite a lot of vibration. I'm not sure exactly what it's coming from. I think a lot of it is the hot end fan, actually. It causes a lot of vibration by the time it gets to the bed. We'll do that, and then while you obviously do want to get it as good as you can using this method, I do tend to also do a first print that's kind of a fairly large flat surface, and you can kind of look at it as it's printing and adjust it there as well. There's so much vibration, it's difficult to get this right. That should be okay for now. So we've done all that whilst hot, by the way. That's why we did the preheat. So back to move axis. Let's just move the nozzle away from the bed now. And we'll remove the paper from there. It's actually, the motion I don't think is as quiet as it could be. I think they are not using as many micro steps as the stepper drivers are potentially capable of. Or they're doing interpolation which isn't enabled or not working or something, because I've had 2208s quieter than this. I wonder if it's in here. Well, this could give us a hint. There you go. That tells me that they're using, there's not enough steps per millimeter there for that to be 256 microsteps natively. So it's probably by interpolation, and it may not be using 256. May not even be using 128. So potentially, while I can't confirm, I would guess that you could improve the noise on this machine just by modifying that firmware. These are not A4988, surely. It's claimed to be a silent stepper board. I can't check, well, I didn't want to check them because they've got their thermal paste on. Someone said I can use IPA to remove it, but I don't really want to do that. I can't believe they put A4988s on this version 4.2 board. This should be the V2 style board. This is the version 4.2.2 board. From people that were talking earlier, that is the same one that's in the V2. I could probably even get the V2 and check, because it's just over there. Maybe we'll do that when we're printing. Yeah, there's no TMC menu. I'm pretty sure they've just used the same old firmware, which is why it's not necessarily as quiet as it could be. Stealth Chop doesn't necessarily need to be on in order for it to be very quiet. So now we've got the bed leveled, we do need to obviously insert some filament. So we've got this nice blue PLA, and we need to find something to print as well. So you do this by clamping this small extruder at the back. I tend to find that once you've got the filament lined up, cut it so the point is at the bottom, because the filament tends to curl up and avoid the hole. So by doing that, then it should just push straight in. Can you see that? Sort of, a little bit, not really. The cameras are all pointing in the wrong direction now. Push this all the way through till you get some squirting out the hot end. It's only at 200C, so don't expect a particularly high flow rate as you push that manually. It will probably be a little bit stiff. We don't have to step. Oh, they do actually have an adjustment on the extruder idler now. I don't think they had that before. No, it used to be fixed. So the idler used to be a fixed tension. They've now added a screw tension system, I think. Is that? Yeah, so that looks like you can adjust the tension if you want to. I'm going to leave it as it is for now, and that will give it about the same tension as the old design, which I thought was actually sort of okay for most circumstances. If this is A4988, then that is a big disappointment. It does explain why it was a little bit noisier than I would want it to be. Looking at the screen. So I don't think we need to look at the screen so much now. Let's move this camera back out the way a little bit. And maybe back to auto ISO. So we're going to try and print something. Just noticed my lights that were nice and colourful are no longer colourful, they're all just off. They've died. How long have we going? How long is the live stream? 1 hour 46 minutes. We're not even to 2 hours yet, and they've all the lights have just died. Oh well. I need to get some power cables or something for them maybe. So I think we're just going to try and print something that's on the SD card. And then while that's printing, we'll take a look at the Ender-3 V2. Yep. Card inserted. So M2F. Oh, 3.5, 2.5, or 4 hours. What? Oh, I really don't want to print for 2.5 hours. Do I want to slice something quickly? I'm going to slice something quickly because 2.5 hours is just too long for me to sit and watch a printer. I'm going to use my old Ender-3 profile that I've had for a little while. Print something original like a Benchy. I might actually print a Benchy. People didn't seem to like my calibration print that I did last time. Oh, sorry, I can't show this screen very easily, so bear with me a couple of minutes while I slice a quick print. So choose my Ender-3 profile. We'll do a 0.2 layer height. And we'll print out something, maybe, they've got loads of files on here. This SD card's got a bunch of different things on. Some are absolutely huge. A vase, another vase, a climb bottle, why would that? Okay, sure. A tiny little maze. Okay, there. Sort of, okay, a bit boring. Well, let's do this vase, but shrink it down. That's a good idea. We'll vase mode, and then try see how long is this going to take. 2 hours. No, smaller. 1 hour and 11 minutes. That sounds reasonable. I'll probably be able to increase the speed on the screen as well because it's very easy. It's probably printed using quite a slow speed using that profile, so you might be able to just speed it up a bit as well. So that's just going to get on with that. In the meantime, I'm going to crack out the Ender-3 V2 and see what we can see in there. Compare these old control boards, because It seems bizarre that they would call this a silent printer and then put A4988 motors in it. Stepper drivers, rather. So, here we go. Here's one I made earlier. And barely used. The print bed is super dusty. So this is their glass heat bed. That's what glass looks like. I know you know what glass looks like, but this is the Ender-3 one with a special surfacey thing on it. Keep that out of the way so we don't break it. So let's try and open this bad boy up and see what we can find inside. It's heating. Why is it going to 80 degrees? Have I just done it in... Oh, I might have done it not in PLA. Hang on a minute. Slightly extreme temperatures. Try again. Why are these all crazy temperatures? Oh, yeah, okay. Just going to actually shrink it a little bit more. 49 minutes, that's probably more reasonable. Let's try this again. Oh. No TF card, great. This looks better. I've lost chat, sorry. The 115 main board has 2208s, so maybe it does have 2208s. The 115, oh, this is 113. This is very early though. Although that board actually did have trim pots on it, so that is a cause for concern. Don't normally have trim pots on a 2208. This is a screw. Remember, do as I say, not as I do. So that print's just going to get started on its own. Hopefully it's all going to stick just fine. I'll keep a bit of an eye and hopefully try to adjust it on the fly if I need to. We need to have a bit. That'll do. So this one does have exactly the same version of control board. Creality version 4.2.2. So what the hell's going on there then? Exactly the same version of control board. I can't see they would put two different stepper drivers on the same control board version. So do they advertise, or is there any indication of the stepper drivers in this printer? This is the Ender-3 V2. The Ender-3 did not. The Ender-3Xs Pro did not come with a glass bed. I know it says it in the listing, but it does not exist. So if you get one, it may be a bit of a punt. Some of them may come with one, and some of them may not. Interesting, eh? Why the dickens do they have... Okay, I've got the same control board. Let's have a look, see if there's anything on the menus. Have we got a power cable I can use? I thought so, this one. Oh. It's really dusty. So the Ender-3 V2, which is this machine right here, according to the sales page on Creality 3D Official, has 2208 stepper drivers. But that, you're right, that sounds like A4988. I reckon they've configured that with the old firmware and just stuck on the 16th micro stepping, and whatever interpolation is maybe disabled. So you're not really getting any improvement over the standard drivers because the firmware is not configured properly. That seems to be what's going on, because that is not a noise I would expect from 256 microsteps. Kind of confusing, really. The new V2s are now shipped with board version 4.2.7. So who knows what you're going to get? This printer is louder than that one without even doing anything. They've really ballsed up the design of the V2. If anyone ever considered it a difficult upgrade from an Ender-3 V1 to a V2, they definitely didn't help themselves by making it super, super loud. So it's not going to be something that I'm going to be reconfiguring right this second. But I would bet my bottom dollar that... Sorry, what was I saying? I would bet you can reduce the noise of this printer by adjusting the firmware. With exactly the same board version, it's got to be the same drivers, surely. They wouldn't put two different drivers on a single board version. In which case, this one will have the same drivers as the V2, which is advertised as TMC 2208. So that should be the drivers that's on this machine. But this sounds terrible. It's not like terrible, but it is pretty not great. I've got a V2. This is another Ender-3. They're all coming out the pipework now. So this one is an Ender-3 Pro that's got a different control board in it. This is not a Creality control board or 2. This is a maker-based control board. So I hate that beep. It's ungodly loud and totally unnecessary. It's also got a touch screen and all sorts. So if I do let's just move this across there. Oops. It's not doing anything. That's not good, is it? Hello? Hello? Silly English knickets. Wow, that's not great, is it? Alright. No, this is totally inaudible. This is what silence sounds like. You can't hear it because it's silent. Yeah, it's now doing it loads of times because I pressed it loads of times and for some reason it took ages to catch up. I think what happened is the screen boots up very quickly because it's its own processor, I think, on this. I think. And then the board just takes a little bit longer to turn on. Yeah, it has its own processor. So the screen turns on in like half a second and the board takes like 10 seconds. Again, very dusty, but totally different experience in terms of noise level. I'm not sure it's particularly safe to put IPA on hot electronics. That sounds like a recipe for disaster. And I'm not sure. I mean, I know we've had a couple of people say you can put IPA on this hot, this thermal adhesive and it'll come off, but something tells me it can't be quite that simple. I don't know why this main camera looks so dark today compared to the others. It's a bit off-putting, isn't it? It's not really happening, I think. It might, this is the weird thing about this. The shipment order that I got said that I was being shipped an Ender-3Xs Pro. Obviously the box says Ender-3 Pro. There's no glass bed, so that's one of the modifications that's not there, but it does have an upgraded control board. But if Creality have said they're now shipping all older Ender-3s with a 32-bit control board, maybe it is one of these newer iterations of the older Ender-3 Pro design that shouldn't have any additional labeling or lettering and is just the 32-bit change, which may explain the slightly noisy operation and the fact that there's no glass bed. But why on earth is it listed as 3XS if you get shipped what is essentially an Ender-3 Pro in nearly every manner of speaking? Bizarre. Oh, I know. Well, yeah. I was very much under the impression the XS is a Banggood version. But what I was interested in is how that was implemented, in that surely Banggood can't be buying loads of Ender-3s, unboxing them all, replacing the control boards and putting them all back. That would just be bananas. So yeah, it's kind of confusing. I wonder if, I don't know, it seems odd, doesn't it? Maybe when Creality started shipping the Ender-3 Pro, but with this different control board, Creality was still calling it the Ender-3 Pro, but Banggood have decided to call it something different. Or decided to market it as an XS Pro with slightly different things. I did open the electronics enclosure right at the beginning of the stream, and we're only just past the 2-hour mark, so you can probably see it. Yeah, I didn't get the glass bed, so I didn't get any better drivers, it seems. Certainly no better audio, and I didn't get the glass bed. So it's basically an Ender-3 Pro, which I've already had for a couple of years and upgraded and modified, and that's what I've got behind me. So I've certainly not gained a whole lot from this. Put it that way. Maybe I'll have to email the rep at Banggood and say, what's up with this? It doesn't seem like this is what was supposed to be sold. Maybe they just accidentally send me the wrong one somehow. This is the part where I just sit here for a little while. Feel free to ask any questions you have. Of the Ender-3 Pro. Yeah, it claimed a version 1.1.5 super silent mainboard, and it has a version 2.2. Version 4.2.2 not silent really at all mainboard, and no glass bed. It's bizarre. But surely the version 4 is much newer than the version 1.1.5. What? So confusing. Trouble with the Banggood rep is they might not be able to really help particularly very much. And then I don't have any contacts at Creality at all to help me either, so. Opinions on the CR30? I have no idea, I don't have one. Oh, it appears I'm quite tired. 2010. Yeah, go on, let's increase the speed. I'll tell you now, it's just going to get noisier, but... Speed! He's doing that thing. Did anyone watch Tom's stream a week or so ago? 2 weeks ago? 3 weeks ago? I can't remember what it was. One of the recent live streams that he did, he had this issue where it was just pausing every now and then. I think that's what now this is doing. I think that was related to SD card performance in the end, but I'm not totally sure. I'm not just going to ask people to send me stuff. That's not a very British thing to do, I don't think. It feels rude. She's got plenty of stuff to get on with. It's not her job to send me things. I'll find someone whose job it is to communicate, and we'll see what we get to. Could sit here and just write an email on my phone. But... I don't have opinions on the CR30 because I do not own one. I have not tried it. I think I might have looked at one that's similar. Let's see. Oh, that's the print mill. Oh, well, no, I don't have one at all. I don't expect I'll be getting one either. Yeah, we're into blobby territory now. For some reason it can't keep up. It's really, really struggling. Looks a bit better now. 125%. I'm not sure exactly what that is, millimeters per second. Any third of the way through. What are the questions? What are the things do we have to talk about? Yeah, I saw that. I'm not sure quite what his problem with it, and what the problem with the machine was. I had an issue very similar on this machine behind me that I was testing a little bit after the stream, like a week or two ago. And it will basically only read stuff that was on this SD card. The SD card is write and read protected. You can't change it, format it, or anything. And it just doesn't read one of the standard G-code lines. Excuse me, I'm very sorry. I just can't find or remember which one it was. Otherwise, I would have let Tom know, and he could maybe have tried that. But yeah, there was one line of the start G-code, like had to be in a specific order that was really not standard, or one of the lines it wasn't reading, or something. I can't remember exactly what it was. Have you ever looked into Clipper? It has resonance compensation and input shaping, which quite literally removes ringing at high speeds. You know what? People have been mentioning Clipper to me for like years. When I made the I almost don't even want to bring it up, but the inconsistent extrusion issue 602 thing from years ago. Clipper was being released or starting around that time, or maybe it was related to that specific issue. in the little community that sort of came up around that sort of time, and they were all using it and suggest I did, but it always just seemed like a bit of a faff to me. So I never tried using it. I don't deny that it can do the things it says it does. Sometimes I just don't have the inclination to do some things, and that just is one of them for some reason. Quite happy to put a lot of effort into stuff, but specific things I just don't want to do for some reason. I guess at the start it was a lot, it's kind of quite new, so there wasn't that much in terms of instructions or troubleshooting or help, so I avoided it for that reason. Especially when I'm trying to make a video, it can be quite frustrating to basically be spending hours debugging stuff. So, and it's not particularly my area of skill, debugging firmware, so I stick to what I know as much as I can. How close are we? 44%. It's not a particularly exciting vase. The model that it had in it was like flipping huge, so it would have barely fitted. I should mention, thank you very much to Banggood for sending me this machine over. Well, even though it's probably not quite what we were expecting. Yeah. There's a link in the description below, an affiliate link for Banggood. So if you want to buy one, as far as I can tell, this is basically an Ender-3 Pro, although we're a little bit confused about exactly what it is, as it didn't necessarily match the listing. So what I can do is recommend the Ender-3 Pro, but I didn't put a link for that. But you can find my video on the Ender-3 Pro and Ender-3 if you want either of those printers. Both fairly good, low-cost options. Though 32-bit control boards with more silent stepper motors than this would be a good recommended upgrade. It looks like we're still getting some of that blobbing from just very short pauses. Of course, because it's a vase mode print and it is a continuous spiral, there is no like individual layer change. There shouldn't be any stopping. Are you using Cura 4.7? No, I don't really use Cura much at all, to be honest. I tend to use Prusa Slicer because it's kind of what I just got used to. Where did you hear that news about the no Noctua fans being shipped? Presumably they're putting in a different fan. I did look at Super Slicer briefly in the background. Wasn't that the one that's also based on Slick 3R? Or based on the alternative improvements from Prusa Slicer and with some additional add-ons and stuff? I did look at it, I just didn't see enough benefit for me to try and invest time into it. So over 100 people watching and only 28 likes. 33 now. I'm sure we can still get more. Literally just click the button if you haven't already. Click that little like. Job done. Then you can leave it alone. Easy peasy. Have you seen the new support paint feature on Prusa Slicer 2.3? I did see the little demo. I know Mickey has made a video about it. I think I saw on Twitter. I've not watched that full video recently, but I did see them demo it on their live stream, the Prusa live stream thing that they did. Oh, well, they do like weekly, I think. So yeah, I've seen it. It looks pretty fancy. Not used it myself. I tend to do my prints tend to come into two categories: things that I've designed that generally don't need any support material because I think it's a pain in the ass, and I do everything I can to avoid it. Or prints for clients, which is just covered in support material and basically need it everywhere because they've done absolutely no design optimization and don't want to spend anything to do it. So it tends to be like those two extremes. So hopefully for the like extreme case of needing support material, I will be able to reduce it by that kind of little more advanced method for applying supports. Let's hope so, anyway. Oh yeah, I did see the like you can just like import pre-made models for calibration stuff. That was quite cool. Yeah. List number of steps, start and increment. Done. Yeah. I mean, they swapped to black fans ages ago. They were supposed to be black from day one, but they weren't. They took a while to get those all in, I think. What are we on? 58%. It smells a bit. I think I'll stay back. The sound of the printer might have spiked when I got a bit closer to it, but otherwise, no, it's been the same the whole time for me. But if you looked away and didn't notice me leaning in, then yes, it might have suddenly sounded louder. Yeah. Microphone closer to loud object makes it louder. Classic. Just do a bit of tidying up while we're waiting. What do you think about the Core XZ Voron switch wire? Well, I've heard of Voron in general. Core XZ sounds interesting. So the XY kinematics are used for X and Z in order to achieve a belted Z, by the look of it. And then you still have the bed sliding. What? I mean, sure, that's kind of... It's cool that it's different. But, I mean, belted Z is kind of... It can be useful because lead screws can often be a bit bent and that can introduce some Z artifacts. Yeah, it'd be interesting to try. But I mean, these are kit things that take hours and hours to buy everything and get it all together. So unless somebody sends me a kit, I'm probably not going to be looking at it any closer than that, unfortunately. But yeah, I mean, it looks entertaining, but I've got no real comments on it. I've not used it, so. Oh, having not printed things for a little while, it doesn't seem to affect my nasal passages a little bit. I'm going to move this a little bit away from me. My nose just doesn't like the fumage. I can't really smell it, but it definitely makes me sniffly. The switch wire recycles most of its parts from the Mark III already. Oh, interesting. Oh, they're going to make an upgrade kit from the Prusa to... Oh. These like totally overhaul upgrade kits are a strange thing to me. That Ender-3 to Core XY, wasn't there an upgrade kit for that? I was like, what? It's just like, just buy a different printer. It's going to cost the same amount or something. I don't know. It seemed odd. I guess if you're already in that mindset, maybe, I don't know. Yo, 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 3D check tech. Yo, yo, yo to you indeed. Yo-yos. Now that's a thing that I've not used in a while. Oh, I'm getting really sniffly. Oh, this is bizarre. Apologies for the constant sniffing. I'm going to get a tissue quickly. I'll be back in 30 seconds. Right, I'll be back quite soon. Okey-dokey. Prusa mods. MGN12 and Chimera. Very nice. The Mark III in the background does use the bare axis. Yep, that one over there. The bare X-axis upgrade. Or bare axis modification, I should say, strictly. I need a chat that's like in front of the screen so I don't face off to the side the whole time. There's just no space in this room to do that though, unfortunately. That and I don't really have the funds to buy like a big TV. That would be kind of nice. How are we doing? 83%. We're getting there. The Ender Extend upgrade. 400 by 400 build plate goes for about 150. You can upgrade the Z height for more. Jesus. Triangle Labs mirror clone is coming out. They're calling the Matrix extruder. Well, I guess it was only a matter of time before they cloned it. It's going to be interesting to see what they do. I wonder how close to the mirror it will actually be. Just quite a lot of waiting at this point, isn't it? Watching it print for ages and ages and ages. That's probably a better view, isn't it? Don't need to see my ugly mug the whole time. Although you still can. Putting a pill out for a new big screen. Of all the things to spend money on, I don't think a big screen is really the most pressing issue. But thanks for the idea. You don't have to have any tips for running a farm. I don't really run a farm myself, so I wouldn't say I have any great experience in being able to provide any expertise on that front. I just have a hodgepodge of all sorts of printers all over the place, and I'd never print with them very consistently, so I wouldn't call it a farm by any means. I guess my recommendation would be that you make sure you understand a lot about the printer you're going to be filling your farm with, and do use one machine rather than like 5 or 10 different types of machines. Make sure it's just one type and get lots of the same machine. That way spares, repairs, replacement is all one ecosystem. You don't have to get different bits and firmwares and stuff for all the different types, because that would be a nightmare. That would, I think, would be my only recommendation. You know what would be good? If I had like 2 machines each time, I could build one before the stream, start the print while I'm building it, and then everything would be finished and all sort of wrapped up in a much more concise time frame. Wouldn't that be fancy? Maybe I'll ask for 2 of everything next time. Space for printers is already a massive problem. I think I've talked about this already, so we won't go over it again. Not sure we need this camera at the moment. So, just sort of wait for it to finish, I suppose. There's not much to do in the meantime, is there? Probably going to have a rearrange of this kind of backdrop and set in the coming weeks/months-ish. So there might be some new stuff to talk about up there at some point. Let's go have a look at this orbiter extruder. Oh blimey. It's a bit different, isn't it? Oh god, what is that? Oh blimey. That's quite exuberant, isn't it? Presumably... Oh. Okay, so it's a low torque stepper motor with a planetary gearbox with Bondtech gears. I mean, obviously I've not tried it. Looks kind of interesting, but does the does that actually give you much of an advantage? I suppose the weight, as long as that stepper motor can keep up with the demands. Oh, it's an LDO Motors pancake stepper. Not gonna lie, it looks pretty cool, but I have no idea if it's going to be any good. .5 to 1 gearing isn't exactly low torque. Well, if it's low torque to start with, increasing it by 7.5 doesn't necessarily make it high. It could still be low. I don't know what the actual stepper motor itself torque is capable of. But if the motor can only do like a very small amount of torque, it still might not be enough to compare to NEMA 17s. The Voron V2 can print 300mm. Oh, don't get me started on printing at 300mm a second. Cool, well, the print is finished. So, I mean, this is how you would use a flexible bed. You take it off, and then you flex it, and it makes it easier to remove. In this instance, the print's quite small and tall, so it's quite easy to remove anyway. But when you have much larger prints, it can help quite a lot. And of course, you can, because it's also removable, if you did have multiples, you could potentially put another one on and start printing straight away. So let's just shift this to one side. Pull this camera down to here. And hopefully we can see the print. Not a particularly exciting vase as vases go, but it is a vase nonetheless. How close can we do with this camera? Should be able to go super duper close. So you can see all the little bumps on there. Oh, was that? I just sneezed right into the microphone. I'm so sorry. Sorry everyone, that was probably a bit of a shock. Getting printer fumes back up the nose is obviously not great for me. The actual lines themselves look like they've laid down reasonably well, but obviously you've got these constant blobs, which is not particularly great. There's obviously no retraction, so it can't be that. There's some other kind of lines. I think that's from the micro stepping or lack of enough of it. Bottom layer kind of a little bit white because of the where I pulled it off. overall, not super bad. And we did this at 125% speed, but it still was reasonably slow, to be honest. Right. Before I get too ill, because I appear to now be very sniffly, which is quite irritating, I think I'm going to leave you all and say goodbye and thank you very much for watching. As I've already mentioned, thank you very much to Banggood for sending me the machine, but I probably will be contacting them because I don't think it's quite right. We seem to have received something that's not quite entirely what was promised. Oh, blimey, I am getting very sniffly. I do need to go. So, yes, thank you everyone for watching. Don't forget to like and subscribe. My nose is going to drip. I shall see you in the next one. I'm apparently now really sick, so goodbye, and I shall see you soon.